Hey there, this is Karthik. In this video, I'm going to try out the Leetcode Biweekly contest 45. So if you're someone who participated in this contest and would like to upsolve some of these problems, this might be a useful video for you as I will be sharing my thought process as I go on and solve the problems. So let me try it virtually. Make sure that you hit the like button and subscribe to the channel. Okay, we'll start off with the first problem, sum of unique elements. You're given an integer array nums. Also, I forgot to do one thing. I need to start a pick pen. Yeah. You're given an integer array nums. The unique elements of an array are the elements that appear exactly once in the array. Return sum of all unique elements of numbers. Okay, this is pretty simple, I would say. Also, given these constraints, you could make it much more optimal. But what I'll do is, I will do something really stupid here. So I'll just make a set of unique numbers. I'll iterate through every integer belonging to nums. If x is already present in the set, so if unique.find x is not equal to unique.end, that means that x is already present in the set, then I should do nothing. But if x is not there in the set, then I should have a sum variable in which I should add x, and I should also put x in the unique set. That means I've seen x now. So unique.insert x and some variable sumx plus equal to x. And we can have another integer sum here. At the end of this loop, I'll just return the sum. There are better ways of doing it. This is probably the worst possible way, but it makes my code very short. I think it's right. Let me submit. What? 1, 2, 3, 2, and output is 6. Expected was 4. Why is that? Oh, you need to just ignore any element that act. Oh, so if it's 1, 2, 3, 2, 2 appears twice, right? So don't take it even once. I thought I need to take it once. Okay, so only those elements that appear exactly once. Cool. I'll just go for another core approach. I'll just see what is the frequency of the elements in the array. And I'll be like this. Okay, frequency of x increased by 1 because I saw x, so x appears plus 1 times now. Now I'll iterate over the elements in the map. If the frequency of this element, that is p dot second, equals to 1, so if this guy appeared only once in your array, then you should add it to your sum, otherwise ignore it. So sum plus equal to p dot first, and then you can return the sum. Let me try this now. Yeah, let me submit it. Yeah, let's move to the second problem now. You're given an array of integer numbers. The absolute sum of the subarray this is okay, an array, and I'm thinking about the array from L to R, the subarray L to R. The absolute sum of the subarray this is equal to absolute of, okay, add the elements from L to R, all the elements, and take the absolute value of that. Return the maximum absolute sum of any subarray of numbers. Okay. Note that absolute x is defined as follow. If x is negative, yeah, sure, okay. So I need to find out the absolutes. I need to find out the best subarray here, and the best subarray is given as, okay, L to R, add all the elements and take the absolute of that. You need to find out what is the maximum possible value of this thing. So if you were to do it in n square, you could just try out every subarray and that would do it. But n square is bad because your array size is 10 power 5. Cool. See, what's desirable is that either I achieve a really negative number, a large negative number, and then you take the absolute of that and it becomes positive, so that is desirable, or you take a large positive number. These are the two desirable traits, right? Normally, if you have seen Cadane's algorithm, how it works, it goes on to find out the best subarray, but it only thinks about keeping the sum positive, right? It tries to find out the max sum subarray, Cadane's algorithm. So if you were able to find out the maximum subarray ending at the ith index, what is the maximum subarray ending at the ith index, and also find out what is the minimum sum subarray ending at the ith index, then you can probably think about it like this way. Either your answer is going to be this one, right? You are trying to find out the best subarray ending at the ith index. Either it is going to be this one, or it's going to be the absolute of this one, right? It's going to be one of these. So what you can do is you can run Cadane's algorithm twice, find out what is the best subarray that ends at the ith index, the max sum subarray, and then find out the min sum subarray that ends at the ith index. For the ith index, the answer is going to be one of these. You can find that out. And among all the indices, just see what was the at what index does the best subarray end. Compare all these 2n values, and you will have your answer. So if that makes sense, I can start coding up. So we can have something like a Cadence algorithm. Max sum at I. Also, guys, whenever you have any doubt, make sure that you put that in the comments, and I'll definitely get back. So you can have a vector of size n here, and another vector of size n, the min sum. Probably there are some easier solutions because this is just the second problem. And then if you think about the max sum subarray ending at the 0th index, the sum for that array is going to be nothing but nums at 0. Similarly, about min sum subarray ending at the 0th index, that's also going to be nums at 0. Because there's only one subarray that ends at the 0th index, and that is 0, 0. Now let's try about the other indices. I'll start from the first index I up till n minus 1, and I'll find out maxsum and minsum for all of these indices. So maxsum at I is either going to be nums at I, or see, just take the ith element and your subarray would be I comma I, right? Only one element. Or you take this and whatever was the maximum subarray that was ending at the I minus 1th index, and you extend that subarray. So it's going to be either nums at I or nums at I plus whatever was the best subarray ending at I minus 1th index. Among these two, choose whichever gives you a better answer, right? So maximum these two. Similarly for minsum, your answer is going to be either only the ith element, so nums at I, or it's going to be the ith element plus you extend whatever was the minimum sum subarray ending at the I minus 1th index, you extend that. So either nums at I or minsum at I minus 1, extend that, whichever gives you a smaller answer, because now I'm interested in finding the minimum sum subarray ending at the ith index. Now for each of the ith index, I know what is the min sum subarray and the maximum subarray. I'll simply iterate through all these indices and find out my answer. Let's say integer answer is currently, I want written the max absolute sum. Okay, let's assume that the answer currently is 0, and it will definitely get updated. And you'll be like, okay, my answer is going to be maximum of the current answer or the maximum subarray that ends at this particular index, and make sure that you take absolute of that. This absolute thing returns an double, I guess. So what I should now do is, if maximum at I is negative, is less than 0, then maximum at I should become positive. How do I make it positive? Maximum into equal to minus 1, right? Similarly, if minsum is less than 0, you will take the absolute of that value. So, and when you take the absolute of that value, it becomes positive, and the quantity stays the same, but it becomes positive. So if either of these is less than 0, you multiply it by minus 1 and make it positive. Now answer is going to be either the maximum answer or and maximum at I, and similarly for min sum at I. Finally return whatever is the answer. Let me run this code. Answer came out to be 5 and it's right. Cool. Let me try out one more case. I don't want a wrong answer right now. It's correct. Cool. I'll submit. Accepted. Let's move to the third problem now. Given a string is consisting only of characters A, B, and C, you're asked to apply the following algorithm on the string any number of times. Okay. Pick a non-empty prefix from the string S where all the characters in the prefix are equal. Okay. Pick a non-empty suffix from the string S where all characters in the suffix are equal. Okay. The prefix and suffix should not intersect at any index. Cool. The characters from the prefix and suffix must be the same. Okay, so if the prefix is AA and the suffix is AAAA, that is okay. Delete both the prefix and the suffix. Return the minimum length of S after performing the operation any number of times, possibly 0 times. So I need to minimize the length of the string by using this weird algorithm given here. And the idea is that you take some characters from the start and some from the back, delete them together. So Let me try these examples. CA would not give you any good idea because you cannot actually delete anything. None of the rules is being obeyed here. So let's try CA, BAC. So what you can do is you can delete CC here, and then you can delete AA here next time. Then you can delete B and B, and you can actually delete the entire string. So what's coming to my mind is a greedy approach, probably, that from the start take as many characters as possible, and from the end also take as many characters as possible and delete them all. Can greedy ever be wrong? Like, if I do have a option of deleting 5 characters from the beginning, right, and let's say this is B, 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 and then maybe a C, a B, and two A's. Let me put in an A here as well. So if I go for a greedy approach, what I do for this string is I'll delete all these 5 and delete these 2 as well. And in fact, this would be a bad idea to do. No, that would be an okayish idea. Because if I ever want to delete this B, all these A's have to go away no matter what. So it's best to delete the entire prefix of the same characters. Otherwise, I will never be able to delete this B here. So I will anyway have to delete all these A's before ever proceeding to this B. So I think the greedy is the right way to go. Because unless you delete all the same characters from the left and right, the remaining characters do not get exposed for deletion. Cool. That makes much sense to me. So the string is up to 10 power 5. What I'll do is I'll probably run a 2-pointer. I'll see what is the character currently on the left and the character currently on the right. As long as I'm getting the same characters, I'll keep increasing these two and I'll consider them deleted after that. And if the left characters and the right characters are not the same, that is the point where I exit and I say, okay, whatever string is remaining in the between a portion, that stays, and that is the length that I will have to keep. All right, let's move to the implementation. So probably 2 pointers, so integer I or integer start equals to 0. I'll start from the 0th index, and another pointer would be at the ending point. So last character is dot length. Length is at least one code. So while start is less than last, first would be better. So while first is less than last, we'll go like this. Okay. And what is the character in hand? That also matters to me. See here, what I'm thinking currently is, what is the first character, and you take all the characters till you're getting the same character. Okay. So I can let me initialize f to a question mark. Currently, I don't know what the characters are, and this is just trying to do an implementation. We'll see. We'll change as required. So while first is less than last, so if you're first, see here's what you do. If the character that is at first is equal to f, that was the character on the left portion of the prefix of it, right? Imagine that you're currently at this position, you've traversed all these a's, you're here. So you should increment this guy to this one if the next one is also an a, otherwise you should stay here. So if s at first plus 1 equals to f, okay, this is getting a bit confusing. I should probably come up with something smarter instead of doing this thing, right? I should not be doing this. Instead, what I'll do is I'll make groups, and I'll have this one. Group 1 consists of what people? It could be A's, B's, whatever. Then I'll think about group 2. What are the characters in this group? Then group 3, I'll make groups. That's a better idea. It will give me a cleaner implementation than that stupid loops, right? So let's just go for the group idea. And if the first and the last group are same, you can delete both the groups. You can drop them. So let's have this thing. Set char groups. Vector of char groups. And then I less than s dot length. See, if the I'm currently at the ith position. Let me make it I equal to 1. So we'll go to this implementation thing. See, I'm currently standing here. Okay. And I'll think about this group. Or should I start from here and put it, okay, that the first group is going to be of A's. And as long as I keep getting the same character, just keep ignoring it, right? Yeah, that makes no sense. So what you do is, the first group by default is going to be that of the first character. So S at 0. So this is going to be your first group. These characters are going to make the first group out. Also, should I maintain their length? The remaining groups, I would like to know their lengths also. So let's go and maintain the length as well. Let me have a pair, char, int, and yep, 1. Alright, now I'll see the current character that I am at right now. Okay, so if I set I, also I can start from the first because the 0 I've already dealt with. I've already declared, okay, there is a group of A's at least of length 1. Okay, now if I set I equals to the previous group, so group set back of dot first. So if your a set I is the same character as the f my I minus 1th character, then it's going to go into the same group. So just increase the length of the group by 1. So you will say, okay, then do this. Groups, uh, group start length size minus 1 dot second plus plus. Else make a new group. Else groups dot pushback. Make a new group of this character. Now that makes much more sense to me. So let me just run this course, or let me just complete the implementation and we'll see. All right. Yeah, this makes kind of sense. So what this is doing is, if you have an input like AA, BB, AACC, then what it will do is it will say, okay, there is a group of A's of length 2, a group of B's of length 2, another group of A's of length 2, and it says another group of C's of length 3. This is what it's basically trying to build, this simple loop. Okay, let's move forward. Now I have these groups. If the first and the last group are same, I can drop them. Okay, so start group equal to 0 and end group equal to groups dot size minus 1, while start group less than end group. So if start group and end group have the same characters, drop them. So if group start group dot character first is the same as group set end group, drop them. Was it implementation based or am I just bad at implementation? So end group first, if these are same, then drop the starting group and drop the ending group as well. Now if you start group after dropping all these groups, also if these are not equal, then what you should do is you should break out of the loop, because now no more deletion can be done. Now if after this looping start group is less than end group, then just find out what is the length of the remaining groups. So while start group less than end group, integer remaining length equal to 0. And what I can do is I can iterate from start group till end group, and I'll keep adding whatever is the length of the groups. So remain length plus equal to groups dot start group dot second and start group plus plus. Okay, I think this is still not that bad of an implementation. Looks neat, at least to me. Let me know in the comments if you like the implementation or if you think it's pretty messy. Whatever you think, do let me know. Your answer is one which is wrong, so it's definitely a bad implementation, I guess. If si equals to groups dot back dot first, else groups dot pushback is set I, comma 1. I'll just print out what are the number of groups that I made, because I think that is going to be the trouble. Okay, so I did make 2 groups, but my answer is wrong. Okay, it should be start group less than equal to end group. My answer comes out to be 2. Let me try this one also and I'll submit then. Okay, it's saying 2, 2, 3. Is that right? It's 2. This is wrong. This one is right, 3. So I need to debug it for this one. It gives me a 2 as an output. What I can do is I can just print out the groups that I formed, and that would help me tons. So for every auto ampersand group present in groups, see out what is the character of the groups. So see out gr dot first. Might help. So for C, A, B, A, A, B, A, C, C1, A1, B1, A2, B1, A1, C1. Groups are right. I'm forming the correct groups. Answer is somehow coming out to be incorrect. Ah, I think I know why. Because when I have only one group left, I can actually go ahead and delete that group as well. Right. What's happening is this A group, I'm not doing anything to that, but this A2 is basically 2 groups of 1A each. So if I'm left with only one group in the end, I should probably delete it, right? So if your start group equal to end group, a start group and end group became equal, why not just go ahead and delete them? Yep, it's giving the correct answer. Now let me submit. Output 0, expected 1. Delete all these B's. Let me try this one. What I would do is I would delete all these B's first, along with the last 3 B's. Then I have an A and an A at that side as well. Oh, if the last group is of size 1, then I cannot delete it. Okay, okay. Thanks a lot, Leetcode, for telling everyone that I'm a noob. So if your start group and end group are refer to the same group, okay, if they refer to the same group, and if the group size of that group set, if this is equal to, if this is anything greater than 1, then you can go ahead and delete this group. So you can say, okay, start group plus plus. So now no more group remain. Great. And if the size of this group was 1, then you cannot delete it. Otherwise, you can delete the last group happily. Okay, I hope this runs now. Yep, it got accepted. Let's move to the last one. Maximum number of events that can be attended to. You're given an array of events where events set I equal to start day, end day value. Let me just check if I'm recording. Yeah, yes, I am. You're given an array of events where events set I start day, end day value. The ith event starts at start day and ends at end day. Okay. I know the starting of the ith event, I know the ending of the ith event. And if you want to attend this event, you will receive a value of value I. So attend, okay. So by attending that event, you will get a value. So by like you are watching my video, you are attending an event, you're getting some value out of it. That makes a lot of sense to me. The value is pretty high. Make sure that you subscribe. Now you're also given an integer k which represents maximum number of events you can attend. Okay. You can only attend one event at a time. If you choose to attend an event, you must attend the entire event. Note that the end is inclusive. That is, you cannot attend 2 events where one of them starts and the other ends. Return the maximum sum of values that you can receive by attending events. Okay. We want to maximize the value that we get, and these are the events that are given. So you have event 0 starts day 1 and goes from day 1 to day 2, and you get the value 4. Event 1 starts from 3 to 4, you get this value. Overall, you're getting 7 value as sum. And in the example 2, you can get 10 value by attending this event. Start day, end day are up to 10.9. You cannot apply DP on that. The value that you're getting is 10 power 6 at max for each event. And the number of events, how many events are there? Okay. What is this K once again? The maximum number of events I can attend. You're also going to represent the maximum number of events you can attend. Okay. I can attend a maximum of K events. Sorry about the handwriting. It's my mouse. So I can attend a maximum of K events. And kind of makes sense to me. If I take the events and sort them according to their endpoints, see, the idea is somewhat like this. This is event 1. This is event 2. Then you have more events like this. Let's say event 3. Let me open Sublime. This is a good question. Okay. So this is your event 1. Then this is your event 2 probably. This could be event 3. I'm sorting based upon their endpoints. So might be helpful. Now let's try to see what, let's try to find out the answer. Let's say this is event 4. Now I may attend event 4 or I may choose not to attend event 4, right? At this point I have two options, either attend event 4 or do not attend it. So if I do go ahead and attend event 4, then I will get whatever is the value that event 4 has. I will get the value associated with this event, and then I cannot attend any event that ends to the right of where it starts. So it's more like, what is the, once you have chosen this, you would be interested in what is the maximum value that you could get from all the events that end before this point. Somewhat makes sense to me. Okay, so what you can do is, after selecting this, event 2 and 3 automatically got discarded. They are no longer helpful. All was left was only event 1. You would select it. If you do not select it, then the problem reduces to finding what is the best answer for these 3 events. So you can see that a DP is popping up. You can think about it like this: DP of initially have n events. So given these n events sorted according to their endpoints, given these n events available to you, what is the maximum value that you can get given that you select at most k events, right? And your transition would be something like this: the nth event either you will select or you will not select. So you have two options: select the nth event, the last event, select it. And if you do select it, then some of the events will disappear, right? Because whichever event was ending after the point where the nth event started, all those events are useless for you now. And you will only think about the events before those. So let's say that event I plus 1, I plus 2, and so on till event n minus 1. All these events started after the point, sorry, ended after the point where the nth event ended. All these events were ending after that point. So these events are now useless to you because you cannot select any of these. Otherwise, there will be an overlap. So you would be interested in finding out what is the maximum value that you can gain using only the first I events. So that's nothing but DP of I, the first I events. And you can select obviously K minus 1 among them because you've already selected one. The other option is that you do not select this event. So not to select this nth event. And then your answer reduces to DP of I n minus 1 comma K. Why is that so? Because since you did not select the nth event, all the first n minus events are still available with you. And you can still select k events among those events. So it reduces to DP of n minus 1 comma k, and among these two possibilities, you will select whichever is the better one. Now, what is the time complexity for this? It's going to be definitely at least n into k because that is the number of states that I'm looking at. So n into k for the number of states. The only problem I'm seeing here is that how do I efficiently find out this I? If I'm able to find that, locate that I efficiently, then my solution is good. And actually, I will be able to locate that I using binary search or some kind of set data structure, and that would be pretty quick. N into k is 10 less than equal to 10 per 6, so that's not my concern. Let's do one thing. Let's move to the implementation, and we'll see what happens. You're given these events, and you would like to sort these events. So let's say sort events. Dot begin events dot end and some comparator that I will just write in a few seconds. Bool comp takes in two vectors. This will sort these according to their endpoints. I'll write this later. So imagine this is written. You sort these events according to their endpoints. Are they already sorted? If they are, that would be helpful from Leetcode site. No, of course not. So I sorted these events. Now let me write a DP. Let's say integer DP. I have n events, right? With these n events and DP of n and k. My final answer is going to be what is the best, what is the maximum value I can achieve using uh, all the first n minus events, that is event 0, 1, 2. I have all the n minus 1 events available with me. I can select k among those, right? Should I go for something bottom up or top down? Bottom up would be good because I need some optimization in finding that right I if I select the nth event. So I do need that. Let's see how we can do that. Also, it must be clear to you that for any DPI, if you can select 0 events, then if you're not selecting any event, then the value that you get is 0. This DP of ij represents that what is the maximum value that you can get using the first I events, that is event 0, 1, 2, so until the ith event. What is the maximum value you can get among these using these events, and that you select j of those events. Okay, and obviously there should not be overlap. Okay, a maximum of j events. So let me fill up these base cases first. So integer I goes from 0, I less than n, I plus plus. This is an obvious base case. TP of I comma 0. If you select 0 events, no matter how many events you have, the value you get is 0. We'll see if any other base case is needed, but I think this will do. And then I can return the final answer. No, I'm thinking about the first I events now. So I goes from n minus 1. I should start this way. I start from 1, I less than n, I plus plus. In fact, I should start from 0. And the events that I can select, I'll call it j. This is the number of events that I can select. Starts from 0. 0 is already done. I've filled that up, right? Because this one was the 0th thing. So j goes from 1. I can select one event up till k events at least. And I need to fill this thing here. Thinking about this here, I have two options. Either I select the ith event or I do not select it. So integer option 1 is that you do select the ith event. Or let's say that you do not select the ith event. In that case, you do not get any value. And you can go for dpi minus 1 and you can still select j of those events. So if you do not select the ith event, you will be like, okay, what is the best maximum value you can gain from the first I minus 1 events, given that you select j of those. And the other option, op2, is that you do select the ith event. Okay, you do select the ith event. Let's select it. Selecting the ith event gives you a good value. And what is that value? Vector int events. Let me check how. Okay, this third one is the value, I guess. Event set I. This is a vector, and inside the second one, plus you go for dp of c. Here's the idea. I just selected this ith event, right? I got the value from this event. But now, all these people who are ending after to the right of this point, whatever events were those, are now not available to me anymore, right? So only these events are available to me. This is some j here. I need to find this j out efficiently. If I iterate like this, trying to find it out, that would be bad. What I could do is I could probably go for a binary search kind of thing that will help me find out the first event whose endpoint lies to the left of this line. The first event whose endpoint lies to the left of this line, this I can do it in login. And then I can apply DP on those events. So let's say I found out J, the first event, or the rightmost event whose endpoint lies to the left of this line. This is the jth event. And then I can add DP of J, comma, K minus 1. Hope you get the idea, right? Because you selected one event here, then the number of events that you can select among these is one less now. Okay, hopefully that is giving you an idea. Let me go ahead with this. Locate the first guy whose endpoint is to the left of this line. So pass in the events. Also pass in what point you are thinking about. So this event started where? This event started at this. You want the rightest, the event to the right extreme whose endpoint is before this guy. All right, we'll do a binary search for that. This locate is going to be a binary search. This will locate the event. Among these two options, whichever is the better option, that is going to be my DP of IJ. That's it. Let me implement this location thing now. This is going to be the harder part, I guess, for me. I'm going to apply a binary search to find out the first, the event with the largest ending point, so that ending point ends before this point x. And if let's say the first event, that is event set 0, this guy, let's say this guy ends after or at x, then you are sure that there is no such event, right? In that case, let's just return a -1. So if your location is -1, then just add 0, otherwise go for that. What this signifies is that you selected an event like this, and before this there were two events, both of them were ending to the right of this point, right? So both of them actually got neglected. There's no such good thing that you can do with the remaining events if you select this one. Okay, let me implement the binary search now. So you have this mid. You see whether this event ends to right or left, and according to that, adjust your range. So if events at mid ends to the right or at x, then you should switch your range to the left. Okay. So if this guy ends to the right of the line that you were interested in, this line, if your event ends to the right of this or at this, then your high should change down back to mid -1. Similarly, if this guy ends before x, or let's just have an else if it ends before x, in that case, you'll do either this is the right guy or some guy to the right of this. So your low becomes equal to mid, and it will keep going until your low and mid high coincide, and you will return low. This should hopefully work. Now the comparator thing, I was trying to sort them based upon their endpoints. So the one that has a smaller endpoint comes first. So return I1 endpoint less than I2 endpoint. Okay, let me run this code. We'll see what happens. I got a compile error, of course. Comp A reference to non-static member that must be called. Answer came out to be 7. Is that right? No, of course. Oh, it's right. Oh my god. Don't tell me that I got it right in one go. Mm, 7 and 10. Why is there no third output? 7 and 10 are right, but why did I not get a third output? Let's see. Okay, it's giving a time limit exceeded for this one. Probably I'm getting stuck in this loop. Most likely I'm getting stuck in that loop. Yep, definitely. Why do I get stuck in this loop? So if low and high are like this, if let's say if low equal to 1 and high equal to 2, then I'll do 1 plus 2, that is equals to 3, and 3 by 2 is again 1. So I'll go on selecting low again and again and again. That is getting me stuck in there. And then low stays the same, so nothing is actually happening due to that. What I can do is, if low and high are like one position apart, I should select high, because that's better. So I'll do this. Yeah, let me go for this one. I'm getting an answer as 9, and I think we got it. 7, 10, 9. Let me submit. Okay, I'll get a wrong answer again because I have not used long. Probably I'll get a wrong answer. Oh, it got accepted. So guys, if you like this contest and the way I helped you to solve the problems, the way I approached them, if you think this was helpful, make sure that you like, share, and subscribe to the channel. Also, do put in a comment to let me know that this was helpful. That would I would really feel good that.